Welcome. In this lecture of linear differential equation with constant coefficients, we solve the example when the right hand side of the linear differential equation x is equal to e raised to ax. When x is equal to e raised to ax, then what is the particular integral? So before that we take here the example. So that is dqy by dx cube minus 4 d2y by dx square plus 5 dy by dx minus 2y is equal to e raised to x. Okay, the given equation can be written as d cube minus 4d square plus 5d minus 2y is equal to e raised to x. So by using the operator d, capital D, that is d by dx, the given equation becomes like that. Okay, so what is the auxiliary equation? The auxiliary equation is d cube minus 4d square plus 5d minus 2 is equal to 0. So this is a third degree equation, algebraic equation. So we have to find here the three factors of that equation. So this equation can be written as, so d cube minus d square minus 3d square, okay, plus 3d plus 2d minus 2 is equal to 0. Okay, so because d square minus 3d square is minus 4d square and 3d plus 2d is 5d. So taking out here the factor, so that is d square. So in bracket d minus 1, again we take minus 3d from these two terms, so we get here in bracket d minus 1 plus 2 into bracket d minus 1. So this is equal to 0 here. Okay, so taking out d minus 1 in this equation, so this is a factor. Then in bracket remaining here, so that is d square minus 3d plus 2 is equal to 0. Plus 2 is equal to 0. So what is this? So this is the quadratic equation. So what are the factors of this quadratic equation? So that is d minus 1, d minus 2 is equal to 0. Okay, these are the factors of this quadratic equation. So put d minus 1 is equal to 0 separately. D minus 1 is equal to 0, d minus 2 is equal to 0. So we get the roots of that equations are 1, 1 and 2. So these are the three roots of the equation here. Here the root 1 is repeated 2 times. Therefore, what is the complementary function? Okay, so what is the complementary function? So complementary function is the one part of the complete solution. So what is the complementary function? So that is c1 plus c2x. What is into e raised to x? Because so root 1 is repeated 2 times. So this is m1. This is m1, m2, m2. I think this is say m1 and this is m2. m1, m1, m2. Okay. So c1 plus root is repeated. Then what is cf? c1 plus c2x into e raised to m1x. m1 is 1. 1 into x. E raised to x. Plus c3 e raised to m2x. So that is 2x. So this is the complementary function. Okay. So now we have to find now particular integral. So what is the PR? So Pi is equal to, so 1 upon f of d x. Okay, so 1 upon f of d x. So this is integral operator, 1 upon f of d, operator on x. So then what is the 1 upon f of d? F of d is what? So that is, you take here this or this. So that is d minus 1 into d minus 1. So the d minus 1 bracket square into d minus 2, d minus 1, d minus 1, d minus 1 bracket square into d minus 2. And what is x? X is this, e raised to x, e raised to x. Okay, so we know the formula to find the particular integral. So what is the formula? So 1 upon f of d e raised to ax is equal to 1 upon f of a e raised to x when f of a not equal to 0. So put d is equal to a here. So we get this solution of this particular integral. Put d is equal to a. So we put 1. So what is the coefficient of x? So that is a. What is the coefficient of x? That is 1. So a is 1. A is 1. So put here. Where put? So this equal to 1 upon d minus 1 bracket square. D minus 1 bracket square. Put d is equal to 1. 1 minus 2 e raised to x. Why you are not putting d is equal to 1 here? Putting d is equal to 1 in this factor, but why you are not putting d is equal to 1? Because if we put d is equal to 1, the 1 minus 1, 0, so 1 upon 0, so that is what happened? Method get fails. So we just put in this factor d is equal to 1 coefficient of x. Okay, so this is equal to minus e raised to x divided by 1 upon d minus 1. So this is minus 1 d minus 1 bracket square e raised to x. Okay, so what is the particular integral? Again we find the particular integral here. So 1 upon d minus 1 bracket square. So this factor is repeated 2 times, and this factor, if we put d is equal to 1, so this will becomes 0. So this is 0 factor repeated twice. Then by using formula we see in the last lecture. So directly we have to find here. So if we repeat it 2 times, then what happened? So minus e raised to x into x square by 2 factorial. Okay, x square by. So this is minus here and this is as it is. Okay. So if this factor d minus 1 is repeated 3 times, then what happened? So this is e raised to x into x cube repeated 3 times. So this is x cube divided by 3 factorial. Okay. So therefore, the solution is, complete solution is what? Y is equal to CF plus PI. So what is the CF? So this is CF, C1 plus C2x e raised to x plus C3 e raised to twice x in plus pi, so that is minus e raised to x square by 2 factorial. So this is the solution of the differential equation. Okay, so we take another example. What is the example here? Solve the example. D square minus 9 into y is equal to e raised to minus 3x plus 1 plus e raised to 3x. So right hand side is e raised to minus 3x plus 1 plus e raised to 3x. Okay, so the auxiliary equation is d square minus 9 is equal to 0. So that is d square is equal to 9. So d is equal to what? Plus 3 and minus 3. So what is the complementary function? So roots are different here. Roots are different, not repeated, not complex. So what is the complementary function? C1 e raised to m1 and m2 e raised to m1x. So that is e raised to 3x plus C2 e raised to m2. m2 is minus 3. So minus 3x. So this is the complementary functions. Now we have to find here particular integral pi is equal to what? 1 upon f of d x. So this is equal to, what is f of d? F of d is what? So this is f of d. So 1 upon d square minus 9. So what is this? X is this, right hand side, capital X. So e raised to minus 3x plus 1 plus e raised to 3x. So we operate this factor separately. So that is 1 upon d square minus 9 e raised to minus 3x plus 1 upon d square minus 9 into 1 is there. How to operate that? So that is e raised to 0 into x. E raised to 0 into x, that is e raised to 0, that is 1 plus 1 upon d square minus 9 e raised to 3x. Okay, e raised to 3x. So what happened here? So this can be written as d plus 3, d minus 3, e raised to minus 3x plus 1 upon d square minus 9 e raised to 0 into x plus 1 upon d plus 3 d minus 3 e raised to 3x. Okay. So what is the formula here? 1 upon f of d e raised to x is equal to 1 upon f of a to find particular integral e raised to x. Put d is equal to a here. So this is the solution of this particular integral. So this is the solution. Put d is equal to e only. So what happened here? So what is a? A is what? Minus 3. A is minus 3. So we put a d is equal to minus 3. So this is d plus 3. So this is what? Minus 3. Minus 3. So then what happens? E raised to minus 3x. Plus what? Put d is equal to 0. 0 minus 9. Plus d is equal to 3. 3. So that is 3. D is equal to 3. 3 plus 3 into bracket d minus 3 e raised to 3x. Okay. E raised to 3x. So what happened here? Why you are not putting d is equal to minus 3? If we put d is equal to minus 3, then this becomes 0. And method gets fails. 1 upon 0, infinity, method gets fails. So what happened here? So this is equal to so minus 1 upon 6, 1 upon d plus 3 e raised to minus 3x. So this is minus 1 upon 9, and this is what? 1 plus 6 e raised to what happened? Just made 1 upon d minus 3 e raised to 3x. E raised to 3x. So what is how to find this particular integral? How to find this? If we put d is equal to minus 3, so this is a 0. So the 0 factor is repeated 1 times. 0 factor is repeated 1 times. So then we directly solve here 1 upon minus 1 upon 6. So into what? E raised to minus 3x into x divided by 1 factorial. So minus 1 by 9 plus. So this is also 0 factor. 0 factor. Put d is equal to 3, we get 0. So we write here directly 1 upon 6 into e raised to 3x into x divided by 1 factorial. 1 factorial, that is 1 here. So this is a PI. Okay. So what is the solution here? So this is solution is what here? So this solution is y is equal to CF plus PI, particular integral. So what is the CF? CF is this right here plus what is the particular integral? Is this right here? We get the complete solution. So we take here another example. So for you, for homework, take example and you solve that example. So very simple example. solve d cube plus 3d square plus 3d plus 1 y. So this is a very simple example how to solve that example, because what is this? So this is a d plus 1 bracket cube. So what are the roots? D is equal to minus 1 minus 1 minus 1. So what is the complementary function? So minus 1 is repeated 3 times. C1 plus C2x plus C3x square into e raised to x minus x. So this is a complementary function. So find the particular integral. It's so very simple. Okay. So we take another theory. When the right hand side of the differential equation is sin x or cos x, then particular integral when x is equal to sin x or cos x. When x is equal to sin x or cos x, then what is the particular integral? Before that, we study the method when right hand side x is equal to e raised to x. Here x is equal to sin x or cos x. Then what is the pi? Okay. So let we consider here the differential equation. So d raised to n plus p1, d raised to n minus 1 plus p2, d raised to n minus 2, and so on, pn y is equal to x. Okay. Here we consider x is equal to sin x or cos x. Here consider when x is equal to sin x or cos x. Then what is the particular integral? So the particular integral is pi is equal to 1 upon f of, so just write down pi of d square here. Pi of d square sin x is equal to 1 upon pi of minus a square sin x. So that is proving here. Okay. When capital X is sin x or cos x, then particular integral is this. So put here d square is equal to minus a square. So how we have to put here d square is equal to minus a square? That is proving here. So we have. What is the d of sin x? So that is the d of sin x means the derivative of sin x, dy dx of sin x. So derivative of sin x is cos x into derivative of x is a. So okay. So that is what is the d square of sin x? So d square of sin x means again derivative of this. So this is what? So this is sin x derivative is minus cos x derivative. That is minus sin ax. So that is minus sin ax into derivative of x is a and into a. So that is a square. Okay. So what is the d cube of sin x? So again we take what happened here? D cube of sin x. So that is again we take the derivative of this. So what is the derivative of this? So this is similarly minus a cube cos ax. So what is the d raised to 4? Sin x. d4 sin x is equal to. So again we take derivative of this. So cos x derivative is minus sin x. Minus plus. So this is a raised to 4 sin x. So this can be written as, what happened here? So minus 1 raised to, so just minus a square raised to 2 sin x. So a raised to 4 can be written as minus a square raised to 2, so that is a raised to 4. Okay, and so on. D raised to n sin x is what here? So this is minus a square. So that is what happened? A square raised to n sin ax. Okay, so this is very simple one. So if we consider phi of d square, this function, what is the function of d square? So put d square here. So this is the theorem apply for only d square. So phi of d square. So what is the phi of d square? Put d is equal to d square. So we get that function. So that is what happened here? D square is equal to d is equal to d square. So that is d square raised to n plus p1. What is the d? D is, so this is f of d. I think f of d this is. So what is the phi of, similarly, this is f of d. Then similarly, what is the phi of d square? So that is p1. D is what here? So that is d square. So we say this is f of d. Then what is the phi of d square? Is this. So that is n minus 1 plus p2 d square raised to n minus 2 and so on pn. So this is pi of d square. We say this is pi of d square. Let us consider that. So okay. So now pi of d square. So this is an operator, derivative operator. So that operator pi of d square operate on sin x. Then what happened? That operator pi of d square sin x. Then, so what is this? So this becomes here. So what is the d square? D square is minus a square. Okay? D square is minus a square and so on. So put a d square is equal to minus a square raised to n. Put a d square is equal to minus a square. So d square is equal to minus a square raised to n minus 1 plus p2. P2, what is d square? Minus a square raised to n minus 2 and so on pn. Okay, so this is into sin x, just right here sin x, and this is operate on this, so this is equal to, so if this is pi of d square, then what is this? If this is pi of d square, then this is equal to, so that is pi of minus a square into sin ax. Okay, sin x. So pi of d square is equal to sin ax. So now we operate 1 upon pi of d square. Operate, just this fact operating on both sides. We get. So this is the operator operating 1 upon pi d square operating on both sides on this equation. So this equation becomes here, what happened? So 1 upon pi of d square into pi of d square sin x is equal to pi of minus a square. This is algebraic multiplier. So this is algebraic multiplier. So this is 1 upon pi of d square sin x. Okay, so we operate this factor on this, so we get this. Okay, but this is what? This is a derivative operator. And what is this? This is integration operator. But a derivative operator and integration operator are inverse operators of each other, then they cancel each other. So they cancel each other. Derivative operator and integration operator. So we get the cancel here. So we get sin x is equal to this. Okay. So but what happened here? So pi of minus a square. Pi of minus a square. So this is not equal to 0. Not equal to 0. This is not a 0. We consider here. If 0, then what happened? So this is the next case. So this is, we consider here pi of minus a square is not equal to 0. So if this is a algebraic multipliers, there is no d. So you can divide by this multiplier to this equation. So what happened here? 1 upon pi of minus a square into sin x. Dividing by this factor to this equation. So this get cancelled. So 1 upon pi of d square sin x. Okay. So this is the particular integral. So 1 upon pi of d square sin x is equal to 1 upon pi of minus a square sin x. So this is the particular integral when x is sin x. Similarly, we can find here, put it cos x or cos x, same as it is, or cos x, same as it is. Okay, you can prove easily when putting x is equal to cos x, we get same result like that. Okay, so this is the particular integral. So this particular integral when pi of minus a square not equal to 0. If this is not a 0, then this is a possible. Otherwise, if pi of minus a square is equal to 0, then what happens? If this is 0, so what? 1 upon 0, that is infinity. Means this method fails. Then if pi of minus a square is equal to 0, then what happen? So we take the particular case to solve this when pi of minus a square is equal to 0 in the next lecture. Okay, so we stop here. Before that, I request you to like the video and subscribe the video channel, so you get more lectures on linear differential equation with constant coefficients. Okay, thank you.